notice that this next one is not quadratic. And so I'm going to follow the same process, but here we're not going to have questions like where is it increasing and decreasing. Those start to get into the realm of calculus a little more, and we're not going to go there on this lesson. We're going to find and plot. It says find v plot. It should say find and plot the x-intercepts of that function. That's bugging me, that typo. It needs to be corrected. We shall correct it right now. But when I do, I'm going to plug in 0 right here and set this equal to 0 basically and solve it. So here goes. 0 equals negative x cubed plus 2x squared plus 3x. Okay, here's what I noticed. I'm trying to factor something that has a negative in the front. That bugs me. It's doable, but it's just a little difficult to think about. So I'm going to factor out a -1. Actually, I'm going to divide out a -1. So that gets divided by -1, changes that sign, changes that sign. That should be a cubed, sorry. This changes that sign, and that's equal to 0. 0 divided by -1 is 0. I always look for a GCF first whenever I factor. And I didn't have one here, and I didn't have one here, maybe a -1 perhaps, but I didn't have anything of any significance. So here I do. I'm going to factor out a x. So now I have x squared minus 2x minus 3. And we can continue to factor this. So 0 equals x, x minus 3, x plus 1. And so I have 3 answers. I'm going to go backwards. One of them is -1. It's the opposite. One of them is +3. And one of them is, well, x equals 0. So if I set this equal to 0, I'd get x equals -1. If I set this equal to 0, I'd have +3. If I set x equal to 0, I'd be like, well, x equals 0. So I have 3 x-intercepts, 0, 0, 3, 0, and -1, 0. Let's plot them. 0, 0, obviously the origin. 3, 0, -1, 0. Okay? Let's find the y-intercept, and this one's going to be pretty easy, and actually we've already found it. Because it's a function, it has to pass the vertical line test, meaning if I pass my line, a vertical line through here, I'll only cross the graph at one particular point. And if I'm going to cross the y-axis, I've already found where I cross the y-axis, but just to prove a point, let me do it. So I'm going to plug in 0 here, here, and here. So my y value, also known as h of x, is -0 cubed plus 2 times 0 squared plus 3 times 0. 0, 0, 0. Oh, well, it's 0, which means my y-intercept is, well, 0. If you have an x-intercept of 0 and a y-intercept of 0, then it goes through the origin, right? Okay, what's the degree of h of x? Well, the degree is 3. What is the leading coefficient? -1. Describe the end behavior. We haven't drawn a graph yet. Well, this isn't a parabola, so it's really hard to draw it the way it needs to be drawn. So I'm going to cheat a little bit for the sake of learning and grab a graphing calculator. And I know you might be thinking, why don't I just do that in the first place? Because you might, for the sake of time sometime, or just for the sake of understanding, need to be able to look at that and say, okay, what does this look like? What's the basic shape of this graph without always having to graph everything? It's like, you could use a calculator for your multiplication tables, but why would you do that when you should just know what 6 times 7 is anyway, right? So -x to the third plus 3x. All right, when I graph it, it's going to, I'm going to go ahead and show you what it looks like without graphing it. It's going to look like this. It's going to come up and then down and then back up like that. And it's not going to be perfect. I'm not going to have all my points in the exact right place. And I just drew it upside down because I was thinking that my leading coefficient was a positive and it's a negative. Okay, good learning opportunity. I'm not going to start this video over just because I made a mistake. This is what would happen if that was a positive. So this takes us to a conversation about end behavior. End behavior is based on 2 things in a polynomial. It's based on the degree, whether it's odd or even, and the sign of that. And when I drew this, I drew it upside down because I was just going based on a basic cubic that would be a positive, and I was wrong. I had a slight moment of panic when I saw that. We'll make a chart about all this in just a minute, and it'll all make sense, I believe. But the end behavior of this would be, well, whoops, drop my calculator. Up, down, because if you drew the arrows here, you'd have up, then down. So don't make it harder than it is. Up, down. Okay, let's do the next one, and the next one is actually ridiculous, but super easy. So we're going to find the X-intercepts. It's already factored for us. So here we go. We don't have to be like, well, let's find a GCF and let's factor this. And no. X equals -1, +1, -2, +2. And if you want to write the coordinates, which I'll do over here, you'd have -1, 0, +1, 0, -2, 0, +2, 0. Let's find the y-intercept. This one's going to be a little bit harder, actually. We're going to plug in 0 for every x. So f of x equals 0 plus 1 times 0 minus 1 times 0 plus 2 times 0 minus 2. Well, that's 1 times -1 times 2 times -2. -2 times -4 is +4. So we have a y-intercept of 4. Well, it's 0, 4. So let's plot some points. Here, 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 and 4. There it is. What is the degree? Well, it's the highest exponent I see. That's actually a false statement, okay? It's the highest exponent if it's in standard form. If I was to multiply this out and this out and this out, how many? I would have x to what power? Okay, if I FOIL these, I'd have x squared times this one would give me x cubed times this one is x to the 4th. And here's kind of a shortcut. X to the 1, 1, 1, 1, 1 plus 1 plus 1 plus 1 is 4. What's the leading coefficient? It's 1 times 1 times 1 times 1. So it's 1. And we're going to describe the end behavior of this. And when I do, I'm going to go ahead and draw this one without a calculator. I know it has to touch here. You can graph it in the calculator if you need to, but it does this and it goes down. I don't know how low it goes down. But it does that. It comes back up. There we go. So the end behavior on this one is going to be up, up. Alrighty. Let's do one more, and then we'll start making sense of this just a little bit more. We'll do this next one very quickly because it's very similar to what we've already seen. We're going to find the plot, the intercepts, find and plot. Man, ridiculous typo that happens from copying and pasting. We're going to find and plot the x-intercepts of that. So here they are. X equals 0, -1, +1, -2, +2. We can list them as coordinates. 0, 0, -1, 0, 1, 0, -2, 0, and 2, 0. And we'll plot them. And here's this one, this one, this one, this one, and this one right there. Find and plot the y-intercept. No typo in this one. Find and plot the y-intercept. Well, I'm not, and here's why I'm not. If I plugged in 0 here, 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 and here, I have 0 times all this stuff. So it's just going to give me 0, 0. I've already plotted it, right? What is the degree? It is 1 plus 1 plus 1 plus 1 plus 1. So it is 5. What is the leading coefficient? Okay, so what would happen if I multiplied them all together? It would be 1 times 1 times 1 times 1 times 1. So 1. And if I was to graph it, it would be what I had accidentally graphed earlier. It's going to look like this. Now, it may not look exactly like that. It's probably going to have a little more height to it and maybe a little more waviness, and I'm actually going to do that very quickly just to see it. X plus 1, x minus 1, x plus 2, x minus 2, and when I graph it, there we go. Yeah, these ends are a little bit lower and higher than those two, and so it's not drawn exactly, of course. But I can say the end behavior, sure enough, is down, up. So down, up. Okay, let's make some sense of this and put it in a chart. I'm talking about my end behavior, If my degree is even, let's look back at an example that had an even degree. So this one, the previous example, was 4. It was up, and my leading coefficient was 1. Okay, so even degree, leading coefficient was positive, up. Well, if my leading coefficient was negative and my degree was even, it was down. It's like an upside down parabola, which you've seen before. Okay, let's do the one that's right here. The degree was odd and the leading coefficient was positive. It's down, up, and then we've done one like this. It's up, down. So do you have to memorize this? Well, yeah, it kind of comes in handy, but it's something you already know. You really already do. For example, if I had a parabola, if I graphed y equals x squared, it does this. Up, even, positive. If I had y equals negative x squared, it would look like this. There you go. Down. If I had, I'm going to make this like I just made the chart right beside it. If I had y equals x, just x, that is odd, positive, and it would look like this. That's down, up. If I had y equals negative x, that is an odd degree and a negative leading coefficient, and it's up, down. And if you know these, you got these.